The electric eel might have eel in its name, but it's actually a type of fish. With their long, sleek bodies, they look like eels, but what sets them apart is their ability to unleash a powerful electric shock. There are 3 species of electric eels, each found in different areas of South America, and they sit at the top of the food chain with few threats in their environment. From their impressive ability to jump out of the water to catch prey to their intricate sensory systems, there are so many cool things to learn about electric eels. Even though it's called an electric eel, this creature is actually a South American knifefish, and is more closely related to catfish. It's so special that it has its own genus, Electrophorus. For a long time, scientists thought there was just one type of electric eel, but a 2019 study using DNA showed that there are 3 separate species: Electrophorus voltai, Electrophorus varii, and Electrophorus electricus. Each one lives in a different part of South America. The electricus is in the Guiana Shield, the voltai is found in the Brazilian Shield, and the varii calls the lowland Amazon basin home. They all look pretty similar, but the voltai has a rounder head compared to the others. Electric eels might not be actual eels, but they sure look the part with their long, snake-like bodies. Unlike true eels, these guys are freshwater fish that usually hang out at the bottom of murky rivers and streams. The name electric eel is spot on because they can deliver a shock of up to 860 volts depending on the species. This impressive ability comes from 3 special organs found in all electric eel types: the main organ, the hunter's organ, and the sax organ. The main and hunter's organs team up to create the strongest shocks, while the sax organ is responsible for lower voltage bursts. Researchers found that the Electrophorus voltai species is the champ when it comes to high voltage, reaching up to 860 volts. Meanwhile, the Electrophorus electricus and Electrophorus varii can deliver shocks of 480 volts and 572 volts respectively. But it's not just their shocking abilities that are fascinating. Electric eels can also jump out of the water to strike at predators. Biologist Ken Catania from Vanderbilt University stumbled upon this behavior while working with them in a tank. He noticed that when a metal rod got too close, the eels would leap out to zap it with their electric shocks. Electric eels see the rod as a big animal because it conducts electricity. When they encounter non-conductive objects, they just ignore them and don't go after them. In the same research, the eels would bend their necks to stay in touch with their target, making sure any predator feels their full power. Even though electric eels are top predators with few threats in the wild, this tactic is super useful during the dry season, when they might be stuck in small ponds and more exposed. During the dry season, female electric eels create foam nests using their saliva to lay eggs. The males take charge of building the nest and keeping an eye on the eggs until they hatch in the rainy season. Typically, around 1,200 baby eels emerge from these well-protected nests. It's thought that electric eels are fractional spawners, laying 3 batches of eggs in each spawning cycle. Even though they have small gills on their heads, electric eels mainly get their oxygen from the surface of the water. They breathe in about 80% of their oxygen by gulping air, which is a handy adaptation for the muddy waters they inhabit. Since they need to breathe air to survive, they have to come up regularly. With their poor eyesight and muddy surroundings, electric eels have adapted to use their electric abilities for another reason: finding fast-moving prey. Research on the electrical pulses they emit shows there are 3 main types. They use low-voltage pulses for locating objects, short high-voltage pulses for hunting, and the highest frequency and intensity pulses when they're ready to attack. Thanks for watching, and be sure to like, share, comment, and subscribe for more randomness.